Oh, sorry, Nana. I muted my voice. Now I think you are able to hear. Am I right? Now, once you check. Once you check. Yes, yes, yes. Okay. Very good, very good. So I'm coming back to here. No problem, Nana. Nothing what I explained. Once again, I will explain here whatever I took on the board. This is first vector and this is second vector, what I took. Okay. Now check there. Both are quite in opposite direction. In opposite direction, the second vector taken in opposite direction to the first vector actually called as negative vector. Okay. So here I say the second vector b bar is the negative vector of a bar. Okay, that's what I said previously. That's why already we took this point. B bar is equals to minus of a bar. That is, b bar is the negative vector of a bar. Okay. So here what I am doing, I am going to construct two vectors here like p bar and q bar. These are the two vectors what I have taken. Right? And these two vectors, once you check, they are looking like taken in order from the point, red point here. Okay, from the red point. But I want the resultant of these two vectors about the point O. So if I ask the resultant of these two vectors about the point O, they are not looking like originated from O. To consider the other vector, actually P, you look there now, P is originated from O only. So there is no trouble with P. But Q is not originated from O. It is originated from some other point. That's why I'm going to construct a negative vector for Q. Okay. Negative vector for Q here. That implies I'm going to construct like this. This is first vector P bar. And now I'm taking quite opposite direction to Q bar like this. Okay. Now if you check there, here this is P bar, what I have to write. This is taken in quite opposite direction to Q bar. I have to take it as negative Q bar. Okay. This is what I am saying. Actually, these two vectors are given in order. Right? Given in order. If it is the angle theta, while finding out the resultant of these two vectors, then we have to take the angle 180 minus theta. Am I right? Okay. Now, if you take the first vector in opposite direction, exactly both are looking like originate from the same point, and it is the angle, perfectly the angle theta. Right? But it is the angle between whom? Not P bar and Q bar. It is the angle between P bar and negative Q bar. This is the angle. Okay, between the two vectors. One a vector and another one is negative vector of Q bar. Okay. So if you want the resultant of these two about the point O, then I have to construct a parallelogram as usual, like this. I am going to construct the parallelogram here. Okay. Now check there. This is my parallelogram. Now exactly here I'm going to get the resultant originating from the same point here like this. Okay, it is the resultant of the two vectors. This is r bar. Okay, so according to the vector addition concept, okay, in the parallelogram the opposite sides are equal. So here I am coming to the opposite side. Look at here, this is the opposite side, but it is minus q bar. See there. Okay, it is minus q bar means r bar when two vectors are taken in order. What I said, try to recollect. R bar can be written as the addition of two vectors when two vectors are taken in order here. That is p bar addition only I am taking, plus added to whom, minus q bar. So p bar plus minus q bar I am going to write here. Okay. So look at there, finally what I got here, r bar is equals to, I am getting p bar plus of minus, that is negative q bar. Okay, so by the addition of a negative vector with the other vector, finally you are getting there, you are adding, but it is looking like subtraction after adding a negative vector to the first vector. That's why it is called as the resultant. What you are getting there is r bar is the subtraction of two vectors, not addition of two vectors. Okay, better we represent to avoid the confusion between the addition of vectors and subtraction of vectors. Instead of r bar, their addition I took it as r bar. So again, if I take it as r bar, you may get some confusion. So just for your sake, I am changing the letter. Here, that subtraction I am taking it as s bar. So this is s bar and it is s bar. Okay, just later I change it there. That's it. Okay, later while solving, you will get a clarity here. R bar, oh, we use for addition. S bar, we use for subtraction. Simple, like. Okay, then check here. If P bar and Q bar are taken in order like this, from the point O, whatever you are getting here, this is S bar. Now look at the above parallelogram I am going to construct here. This is the parallelogram I constructed. Of course, I did not get it properly. Okay, sorry. Once again, I am going to construct it. Yeah, a little bit better, but it is in the downward direction. It is towards right. Okay, check here. From the below diagram, the vector taken from origin in this direction, in the same color I take to avoid the confusion. Here once you check, who is this black line? This is actually for us S bar. Okay, but look at here, the P bar and Q bar, look at there, means the dotted one parallel to P bar. So surely it is P bar. And the Q bar actually originated from here, the red point, now turned to black. Okay, from there. So check there, I am going to construct. This is yes, Nana. Okay. So I'm going to construct one more diagonal here in another color. Look at that. These two are originated from the same point. Now, which two are? Once you check, P bar and Q bar. P bar and Q bar are originated from the same point. Originated. If you check there, both are positive vectors. So by adding these two, it is the resultant of the addition of vectors, whereas the diagonal started from O when we take the two vectors in order like this. Okay, one diagonal is giving the resultant of the addition of vectors, the other diagonal in the parallelogram, look at there, giving the subtraction of vectors. Okay, now you understood, Nana? One diagonal gives subtraction of two vectors, the other diagonal perfectly giving the addition of two vectors. That's why we say here the two diagonals diagonals of the constructed parallelogram give one the addition of vectors and the other gives us the subtraction of vectors. This is the advantage of constructing the parallelogram. In the parallelogram, both the diagonals are useful for us. One gives addition, other gives subtraction. Okay, originated from the same point gives addition. Okay, the other diagonal here gives subtraction. Right? Is it clear, Nana? Any doubt in this concept? Subtraction and addition of two vectors? Any doubt here? Understood, no doubt. Okay, very good, very good. That's good. Right. Now, here our question is, like in parallelogram law of vectors, after finding out the two vectors originated from the same point, okay, we found the magnitude and direction of resultant vector. In the same way here, we have to find out what is the magnitude and direction of subtraction of vectors. Okay. Now check here. S bar is taken from the same point of origination of two vectors P bar and minus Q bar. Even though it is minus Q bar, the magnitude of minus Q bar, once you check, magnitude of minus Q bar is equals to what I have to write, mod of minus Q bar, that is nothing but mod of Q bar only. Okay, negative mod is also positive. So their magnitudes are equal. And the magnitude of P bar already you know, that is mod P bar. That is already a positive vector, that is equals to mod P bar. So it is looking like P and Q making an angle theta originated from the same point. Okay. Then The resultant, already you know, if two vectors are originated from the same point at an angle theta, the resultant of those two vectors, resultant of these two vectors is S bar. So S bar magnitude is equals to, according to parallelogram law of vectors, root over P square plus Q square plus 2PQ cos theta. Okay, no need to derive. Already we derived in parallelogram law of vectors. Okay, Nana? Then its directions are with the P bar. Look at here. Suppose this is alpha. Then tan alpha is equals. Better we represent with another letter. Tan beta. There, why? Because there we took it as alpha. Here beta. Tan beta is equals to, we write here, same, it is making the angle with the P. So other component has the magnitude plus Q only. Q sine theta upon P plus Q cos theta. Then student may argue, what? Sir, you are writing the same formula for vector addition as well as vector subtraction. Here, same formula you are writing. Okay. If both are same, what is the difference between addition and subtraction? He will ask. Okay. Then to avoid the confusion, what I say, Arinana, first of all, what you have to identify, recognize in the question. In the question, always take the angle between the two vectors when they are originated from the same point. Okay. When they are originated from the same point. Oh, sir, I did not follow your point, sir. Okay, then come to here. Okay. Then all the points here, whatever I have drawn, if you completed copying them, then I will move to next part. Completed the part there on the board. Is it completed, Nana? Yes. Shall I move to next part? Finished. Okay. Then moving to next part here. Then come back to here. If I move to next part, then check here. To avoid the confusion, what you do there, in any numerical, first of all you check what angle has given there to you. Okay. Suppose here he said two vectors are originated like this. Oh, origination. Ammaya, happy. Both are originated from the same point. So directly we can take the angle between them as theta. One is perfectly P bar, other is perfectly q bar. Okay. Now if I ask the addition of two vectors, generally what I said previously, the diagonal taken from these two originated from the same point gives addition of vectors. This is addition. P bar plus q bar means it is r bar. R bar whose magnitude is equals to magnitude of P bar plus Q bar. There is no confusion. But subtraction of vectors means once you check, if I take the angle between these two vectors, why? Because other diagonal gives a subtraction. So I have to take the other diagonal here. Okay. The other diagonal taken here. This is the subtraction of two vectors. Blue one is the subtraction. So this is S bar. Mod S bar is equals to, I have to take mod of whom? P bar minus Q bar. P bar minus Q bar means you have to reverse the direction of Q bar. This is P bar. Okay. So we have to reverse the direction. So reverse the direction means if I reverse the direction of Q bar, then minus Q bar and P bar are originated looking like originated from this point. Which point? This point. So angle between these two is not theta now. What is the angle between the two vectors? It is not theta. In parallelogram, the opposite angles are equal, theta and theta. And the other two angles are 180 minus theta and 180 minus theta. They are equal. So I think you know in parallelogram what is the angle here. If it is theta, then that is 180 minus theta. Okay, is it correct, Nana? Yes, it is 180 minus theta. So look at here. In case of calculation of mod S bar, angle between the two vectors is 180 minus theta. In case of addition of two vectors, angle between the two vectors is theta. So if you follow that logic, it is very easy to find out mod R bar and mod S bar. Okay. Then here mod R bar equals to, happily I write in this example, mod R bar is equals to, these two are originated perfectly from the same point. So the angle between the two vectors given as theta, that implies mod R bar equals to root over P square plus Q square plus 2PQ, happily that is cos theta. Okay. But P bar minus Q bar, they are making in the diagram 180 minus theta. So mod S bar in this case, I write it as root over P square plus Q square plus 2PQ cos theta is 180 minus theta, angle between the two vectors. Okay. So angle between the two vectors P bar, and after reversing the Q bar vector, red vector minus Q bar, angle between the two is 180 minus theta. So cos 180 minus theta is how much? You know, it is minus cos theta. So if I put here, this is equals to root over what? P square plus Q square plus 2PQ cos 180 minus theta is minus cos theta. This is the difference what you get between addition of vectors and subtraction of vectors. Okay. So just try to remember this thing. Okay. Sorry. Try to remember this one. Addition of two vectors. One formula we got here. and this is subtraction of 2. Sorry. Oh, sorry. What happened? This is subtraction of 2 vectors. Try to remember these two formulae. Okay? Right. Good. That's all. These are the two vectors in subtraction. And in this case, if you want to find out the angle, here we write tan alpha with P is equals to, as usual, Q sine theta upon P plus Q cos theta. Okay. Whereas here with P, the angle made, resultant vector, that is S bar, makes how much angle? Suppose that is beta, what I said. Tan beta is equals to, whereas this is alpha, nana. Okay, this is alpha and that is beta. Tan beta is equals to what you have to write? Q sine, angle between them is 180 minus theta, sine 180 minus theta, Q sine theta divided by P plus Q cos theta, cos theta. Angle between the two vectors is not theta, it is 180 minus theta. So 180 minus theta is substitute here. That implies tan beta equals to how much you are getting there? Tan beta is equals to, look at, all of you know, Q sine 180 minus theta, second quadrant, sine positive. So sine 180 minus theta becomes sine theta upon P plus Q cos 180 minus theta, second quadrant cos is negative. So you will get minus cos theta here. Okay. So this will be P minus Q cos theta. So this is tan beta in case of subtraction of two vectors. Okay. So here, this subtraction of vectors, when we come to numericals, how to use? And how to recognize the angle. Major issue is that recognizing the angle between two vectors, Nana. Two vectors means two positive vectors, resultant is addition. One positive and negative, resultant is subtraction. So we have to find out the angle between one positive and one negative originated from the same point. Okay. For that, what I am saying here, look at, in my coordinate system, I am giving the geographic directions like this. Giving the directions here. Like east, west, north and south. Okay. Now what I am saying, one person starts moving in the direction towards east. Okay, better I take another color here. One person started moving in the direction of east first. Okay, completed a displacement of, say, some, here this is 10 meters. Okay, next he started moving in this direction. What? Towards north. Okay, towards north. Towards north, his magnitude is, means traveled a distance of, say, some 20 meters. Okay. Now the question is, by taking this 10 meters as the magnitude of A bar, that implies magnitude of A bar is equals to 10 meters. Means whatever I have drawn here, it is A bar. 10 meters towards east is A bar. And 20 meters towards north is B bar. Okay. whereas magnitude of B bar is given as that equals to 20 meters for us. This is the information given. And here east and north, obviously they are perpendicular to each other. Okay. Now the question is find, this is example. Okay. In this example, what I am saying, find the magnitude and direction of mod of A bar plus B bar, means magnitude of A bar plus B bar and direction. Sorry, what I have to write, magnitude and direction of A bar plus B bar, that is addition, that is R bar, and A bar minus B bar. Okay, addition, subtraction. Addition, almost 1 week we have discussed in the class, so it is very easy, you can understand and you can solve it. So mod of A bar plus B bar means root of, directly we write A bar, they are perpendicular, so no need to check what are the directions. Okay, 10 square plus Pythagoras I am using none, directly they are perpendicular, so Pythagoras I am seeing that 10 square plus 20 square, that is root of 500, root of 500 is 5 root 10. Okay, in the same way, mod of A bar minus B bar also no need to check. Why? Because again they are perpendicular to each other. Perpendicular means Pythagoras. That is also root over 10 square plus 20 square. That is equals to, again you will get 5 root 10. Oh, I can't write here. That is also equals to 5 root 10. So what you understood from this problem, when two vectors are perpendicular to each other, it is very easy to find out the magnitude as well, the magnitudes of addition of two vectors and subtraction of two vectors. That is very easy. Directly you can apply the Pythagoras to find out the magnitude and direction. Why? Because look at here, already given in this page, addition how to calculate, subtraction how to calculate when two vectors are perpendicular to each other. Theta is 90 degrees perpendicular to each other, and 180 minus theta is also 90 degrees. Okay, if theta is equals to 90 degrees, 180 minus theta is also 90 degrees. 180 minus 90 is 90. So the angle between the two positive vectors is 90 degrees. Angle between one positive and negative vector is also 90 degrees. So in the formula, if you substitute cos 90 here, cos 90 is 0 now. 0 into 2pq becomes 0. So this whole part becomes 0 for us. If that becomes 0, then mod r bar you are getting root of just p square plus q square. That's what I wrote here, p square plus q square. Okay, I think you understood. And even here mod s bar is also subtraction of two vectors. Okay, root of p square plus q square minus 2pq cos 90. Cos 90 is again 0. 0 into 2pq, this becomes 0. If this component becomes 0, again mod s bar equals to root of p square plus q square. Again same thing I did here, root of p square plus q square. There I am getting root of p square plus q square. Here also you are getting root of p square plus q square. Okay, means what you understood from this problem, if two vectors are perpendicular to each other, look at the magnitude of mod of s bar, mod of a bar plus b bar, okay, that is the magnitude of a bar plus b bar, is equal to magnitude of a bar minus b bar also. Okay, that's why under note here I am writing what? If the angle between two vectors, or else simply I write in reverse order, mod of a bar plus b bar is equal to the mod of a bar minus b bar, like 5 root 10 and 5 root 10. Then I can say angle between theta between the two vectors is 90 degrees. That is pi by 2 radians perpendicular to each other. Okay. Then you can assume for this mod of a bar plus b bar equals to mod of a bar minus b bar, then theta between the two vectors is 90 degrees. For this node point, you can take this is the proof. Okay. Now, do you have any doubt in this concept, Nana? Once you check in this page, no doubt. Shall I move on to next page? No doubt, no doubt. Very good, very good, very good. That's good. Then we are moving to next page here. Okay, with your permission. Yes, sir. Thank you. Then coming to here. Coming to next page. Ah, right. What? Ah. Now what I am doing there, what I asked Nana, not only the magnitude, we proved there when those two vectors are perpendicular to each other, their magnitudes are equal. Addition magnitude is equals to subtraction magnitude. Magnitude of addition is equals to magnitude of subtraction. Okay, but direction, this is very important now. Finding out the direction is very dangerous. We are just not only finding out the magnitude but also the direction. So first you check there what the displacement of vector A. Okay, that he has given, oh sorry, that he has given towards right. Okay, 10 meters. And later on what he did, the second displacement perfectly perpendicular to each other given. This is B bar, 20 meters. Okay, right. Now what we are doing, this is A bar and it is B bar, and trying to find out the direction of A bar plus B bar, direction of A bar minus B bar. Direction of A bar plus B bar, no need to say, all of you know. Okay, when two vectors are taken in order by constructing the parallelogram originating from the same point, that's why it is the direction of A bar plus B bar. Okay, and keep in mind this is eastwards direction. This is east, keep in mind, and this is north. Okay, in geographic. Now look at the addition of two vectors a bar plus b bar is looking like in between north and east, but not perfectly in the direction of northeast. Why, sir? If you check, northeast means should make 45 degrees now, should bisect the total angle 90 degrees. Okay, but the resultant what you have found, is it bisecting the angle or not? If you check, magnitude of a bar I gave here, this is 10 and that is 20. Now simple mathematics, try to find out alpha here with the eastward direction. Okay, from the right angle triangle directly you can say tan alpha is equals to here what, opposite side by adjacent side, 20 by 10, that is equals to 2. If tan alpha is equals to 2, alpha is not 45 degrees and 45 is 1, this is 2. So alpha is greater than 45 degrees I can say. Okay, that implies alpha is equals to tan inverse 2 and it is not exactly in the direction of northeast. Okay, in between north and east, if you are saying, oh, it is 200%. Huh? Okay, now I think it is better. Oh my God. I have to redraw them again. Nonsense. Sorry, Nana, I kept in 200% zoom. Okay. Again, I'm redrawing the two here. First, this is A bar. This time quickly I redraw, no problem. And this is given as B bar for us. So here, this will be the resultant of the two. This is A bar plus B bar by constructing the parallelogram here. That all of you know. So it is what? A bar plus B bar. And magnitude is given as 10 and 20. Here we are going to find out first the direction. What I said previously, this is eastwards direction, geographic east. And this is what? Northwards, geographic north. Okay. And if you check here, if alpha is equals to 45 degrees, you can say this is perfectly northeast. Okay, if alpha is equals to 45. That's what I'm checking here. Tan alpha equals to how much? Opposite side by adjacent side, 20 by 10. That implies tan alpha is not equal to 1 to say alpha equals to 45 degrees. It is not equal to 1. It is equal to what? 2. I am getting here. So alpha is greater than 45 degrees. So it is not exactly in the direction of northeast. Northeast means this is a corner, Nana. What we say in Telugu, Eastanyam. Okay, it is not in the direction of Eastanyam. Perfectly not in the direction of Eastanyam. Northeast. Okay. Then how to say the angle we got alpha is equals to tan inverse 2? That what I am writing here, you focus. That's why I'm writing in different color. Once you check what I'm writing. Okay. Tan inverse 2, I'm writing like it is making an angle alpha with the east. Okay. So it is making an angle alpha of tan inverse 2 with the east towards north. Why? Because with the east you can say two angles. One angle towards north, other angle towards the south with the east. So I got the angle here with towards north. So I write here towards the north with the east. So north of east. This kind of representation you have to tune, Nana. That is very important. Looking to be little bit complicated. Once again I'm explaining. This alpha is actually the angle with the east only. With the east we are writing like this, of east, with east. Okay, but towards north or towards south we have to check. The angle here I found towards north, so towards north I write here. Okay, suppose if you found 45 degrees here towards south, then I write this 45 degrees as south, towards south. 45 degrees east, that is 45 degrees south of east. And suppose this is 30 degrees, I write this one 30 degrees towards east. Okay, in between north and east, this one I write 30 degrees north of east. Now is it clear, Nana, how to write? 45 degrees towards south of east, 30 degrees towards north of east. Okay, once you check, you understood this point or not? Saying angle towards north, towards south with east. So shall I move? Okay, this is the direction of what? Yes, coming back to here. This is Only addition of two vectors we found on a bar plus b bar. Okay, so we have to find out a bar minus b bar also. Okay, a bar minus b bar, you check here, I am writing on the other side. Okay, a bar minus b bar, so I have to reverse the direction. Okay, so a bar I am taking as usual, this is a bar towards east, but b bar I have to take not upwards, downwards. Okay, why? Because a bar minus b bar we are calculating. Oh, sorry. Here I am going to draw again. This is a, what happened? This is a bar. What happened? Not able to draw here. Is little bit disgusting. Yes, I am able to draw here. Okay. Then next screen, why I am unable to draw? Okay, not accepting here. Okay, no problem. We go to next screen here. Okay, come to here. This is, even here also it is not accepting. Okay. Oh my God. Okay, right, no problem. This is actually eastwards what we are drawing. He gave. Another one he gave towards north. Like this. Okay. So, for subtraction of vectors, what we have to do, Nana? This is a bar. And this is actually given as b bar. But we require subtraction. Subtraction means a bar minus b bar. Direction of a bar minus b bar. A bar minus b bar. So I have to draw the line in what direction? In the downward direction here, like this. Quite opposite. Okay. Now check here. This is minus b bar. So if I start drawing here minus b bar, same line, and construct the parallelogram, minus b bar downwards, a bar towards right, they are looking to be originated from the same point. So from parallelogram, once you check, I am getting the line like this. Okay. This is what a bar minus b bar direction. Now you check in your geographic system, this is the direction of east. This is the direction of what? South. Now look at here, a bar minus b bar is looking in the direction of south and east. That is in between south and east. In between south and east makes how much angle with the east? Beta I am asking. Okay, that beta here we write. Like what? Tan beta is equals to, again from the right angle triangle here, its magnitude is 10. Even mod b bar magnitude is also same, 20. So tan beta is equals to same angle you are getting, 20 by 10, that is equals to 2. that is beta equals to tan inverse 2, but it is in the direction of south and east. So how we write this angle? That implies it lies in between south and east, makes an angle tan inverse 2 in between south and east. So tan inverse 2 with the south of east. Now is it clear now? Addition and subtraction that we got, check there, tan inverse 2 is same angle, but we got there, where is it? I lost the page. How? Oh my god. Is this really? Okay, we have to create new one. I'm not able to find out the previous page, Nana. I think you understood what I have done there. So shall I move to next question, Nana? Okay, right. Thank you, Nana. Now coming to here. Suppose if I give one question to you, two vectors are taken here, like this is the first vector, okay, and this is the second vector, and the directions I am giving here, like this is A bar and it is B bar, okay. In what directions they are? This is exactly towards east and this is exactly in between north and east, okay. Between north and east means the angle here is exactly 45 degrees, right? Their magnitudes are mod A bar, I am saying, is equal to mod B bar. Their magnitudes are equal. Each suppose equals to some 20 units. Okay. Now the question is, find, today we focus on subtraction, not on addition. Find only the direction, not magnitude, only the direction of mod of A bar minus B bar. Okay, simple. So mod of A bar plus B bar we require none, right? Direction only. Sorry, not mod of A bar plus B bar. Find the direction of A bar minus B bar. This is direction of A bar minus B bar. That is S bar equals to how much? I am asking. So first of all, to get the clarity here, you draw the east, west, north, south directions. Okay. Now you take the vectors. First, eastwards A bar we are taking. Okay. I am taking here A bar. This is 20. And he is asking A bar minus B bar. So we have to take the negative vector of this one. Negative vector quite opposite. Look at here I am drawing quite opposite to it. To B bar. Quite opposite to B bar. I am drawing here. It also has the magnitude same 20, but it is upwards. Now it is downwards. Downwards I am drawing. Okay, means actually drawn here downwards, opposite direction. Parallel line I have drawn there to construct the parallelogram. This is minus B bar. Quite opposite. Now look at A bar and minus B bar. Both are originated from the same point. This is minus B bar. So the resultant will come according to the parallelogram like this. Okay. Now check there the total angle between the two vectors A bar and minus B bar. Shall I say this is till here east and south, till here 90, and the extra angle here I am getting, he said that is 45 degrees. Means actually this angle is 45. Means other angle is also 45. This is exactly 45 degrees. Okay. So this is 90 plus this is 45. You follow this point now? Okay. It is 45 degrees. If you draw with x-axis, it is making angle 45 degrees. This is 45. 45 means remaining angle is also 45. Okay. So total angle theta between the two vectors, if you check there, that is becoming 90 plus 45. Altogether you are getting how much? 135. Okay. So by constructing the parallelogram, that to check over there, their magnitudes are equal. Okay. For Monday test already I said, if the magnitudes are equal, the resultant taken from the same point always bisects the angle. Alpha equals to, that day we took theta by 2. I think all of you remember. Okay, this point. So using the concept alpha is equal to exactly bisecting the angle, here no need to find out. Directly I take the direction like this. How? Check there. Here like this. Exactly bisecting. Exactly bisecting. Okay. I am taking here, this is the resultant of A bar minus B bar. Exactly bisecting with the east. It makes an angle. It makes an angle here. This angle. If you check that angle, Exactly, beta is equals to 135 by 2. Theta by 2, that is 135 divided by 2. That I am getting to 6 15 to 7 67.5 degrees. Okay, this is in between what? South and east. With the east in between, with the east, it is making an angle 67.5. Okay, with the east towards whom? South. So angle beta is 67.5 degrees. I write towards south of east. Okay, did you follow this concept, Nana? What I said there? Okay. So I am going to stop the class here, Nana, for today. Okay, bye everyone, Nana.